So, in part B of our exercise, we must find the integral function of our original function satisfying this constraint. Here we can see the formula for the integral function. We will be using that. But here the variable of the integral function is x, but the exercise asks it to be t, so we must be very careful, because we will have f of t, which is a definite integral going from a, which is the point where the integral function is 0, so in our case pi half, and here in the formula the integral goes up to x, because x is the variable of the integral function, but right now the variable of the integral function is t, so the integral will go to t. And now we just have to write f of, and here in the formula we have t, but in our case we already used that letter, so let's just pick another one. For example, x, so we have f of x dx. Now we have a definite integral which we can calculate. In part A, we already calculated the indefinite integral for a function f, so we will use that. So let's just take the primitive function negative 1 over 3 x times cosine of 3x minus pi plus 1 over 9 times the sine of 3x minus pi evaluated at points t and pi half, and of course taking their difference. So let's just write in our limits of integration, and this gives us negative 1 over 3 times t times the cosine of 3t minus pi plus 1 over 9 times the sine of 3t minus pi minus, now let's substitute pi over 2, negative 1 over 3 times pi over 2 gives us negative pi over 6, and the cosine of 3 times pi half minus pi will be simply pi over 2 plus 1 over 9 times the sine of pi over 2. And we can simplify this a bit. We can't do much about the variable, so we will have negative 1 over 3 t times cosine of 3t minus pi plus 1 over 9 times the sine of 3t minus pi minus, and here we can see that we have cosine of pi half, which is 0, so this term is 0, and we have here the sine of 1 half, which is 1, so this term is going to be 1 over 9, so we have to subtract 1 over 9. Now we are done with the exercise.